So, alright. So the process to design the observer controller is similar with the pole placement controller. That's the good for you. Okay. Firstly, you have the transfer function. The transfer function you need to convert to PVF, and then PVF you need to check the controllability. If the controllability is not equal to 0, then you can design the controller, and then you need to divide which one is a compensated, which one is a uncompensated, and then after that, finally you just need to find the K values. Okay. So I want you to guess what is the process to design the observer controller. Let's say I have transfer function. What you need to do the transfer function? You need to convert to which form? OCF. Kan? If you want, you have the observer controller. Firstly, you need to convert to the OCF. Okay, same process kan? And then from OCF, you need to check what? If this one is controllability, this one we name as a observable. Yes. Observability. Is it my correct? My spelling is correct? Observability, I think so. Okay. So it means that what is the rules do you think? If not equal to 0 kan? If not equal to 0, can I design the controller? Yes lah, same thing, same rules. The process are same. Okay, you have the transfer function, you need to convert to OCF, and then you need to check the observability. If the observability is not equal to 0, then you can design the controller. Okay, and then as usual, you need to divide to compensated, and then uncompensated, and finally you need to find, if for the pole placement controller, we need to find the gain value K. However, for the observer controller, we need to find the gain we label as L values. Same thing. So, if you know the process of the pole placement controller, automatically you will understand the process to get the observer controller. Is it clear? You don't need to study two things lah, because the process are same. Don't worry, the formula, everything are given in final exam question. So you just refer to the appendix, so you can see what is the pole placement controller formula, what is the observer controller formula. You just refer to that. However, you must know how to use. If everything is there but you don't know how to use, 0 lah. Kan? The most thing, you must know how to use. Okay. So, this is the pole placement controller kan? How we inject the pole placement controller to this original system. This is original system. So this is system with pole placement controller. Okay? So it means that this x dot ax plus bu is the original system. Then we just replace u equal to minus kx, and then we replace to this equation, and this is the system with the pole placement controller. Easy, eh? But before we can apply the observer controller, we must know what is the process to inject the controller to the original system. So I will explain to you how to inject the observer controller to the original system. So only this part is different. The rest are similar with the pole placement controller.